My name is Alfredo.
My name's Lizette.
And we're going to be talking about inverse relations and functions.
Okay, so a relation, well, first we're going to start talking about relations, right? What is that? Okay.
Yes.
A relation is a set of ordered pairs, so A, B, and an inverse relation is a set of ordered pairs reversing the coordinates of each original ordered pair. So instead of AB, it would be BA.
A function is a relation from a set of inputs to a set of possible outputs where each input is related to exactly one output, f of x.
An inverse function, however, it reverses that function, so it's g of y equals x. And here's an example of a relation. We have q, which is 1, 2, 3, 4, and s is 2, 1, 4, 3. Q and s are inverse relationships because it's reversed. Hi guys, so we're going to find the inverse of this relation. So as we previously said, we have to basically reverse the order of these pairs. So this one here is going to be, instead of negative 2, 3, it's going to be 3, negative 2. All you're doing is reversing the order. This one here is going to be 1, 3. And lastly, this one here is going to be negative 9, 5. And then you close it off. And this is your answer. Okay, so then the answer is the inverse of f is 5x plus 10. Now you can simplify this further by dividing both sides by 5. So this will give you 1x plus 5 or x plus 5. And that's basically your answer.
What we're gonna try to do next is get by itself. So basically it will be x equals negative 1/2 y plus 1. And then after that, what we're trying to do is multiply both sides by negative 2, so it will be x, bring the 1 over here, so x minus 1 equals 1/2 y, and the negative 1/2 will turn to the opposite, so it will be positive, and the 1 from here will turn negative because it's the opposite. And after that, what we're trying to do is put into parentheses, which will be negative 2x minus 1, which equals y, and from there we're going to try to distribute to equal y, so it will be negative 2x and negative 2 times negative 1, it turns into a positive, so it will be negative 2x plus 2, which equals y, and it gives us our inverse relation of f of x equals negative 2x plus 2, which is our answer.
So continuing off of Alfredo's idea, now we're going to graph his original function and the inverse function. So the first one is f of x equals negative 1/2 x plus 1. So we put the 1 here for the y-intercept, and then negative 1/2 would be the slope. So we go down 1 and over 2. So we graph the original function. Now we're going to graph the inverse of it, which is f of x equals negative 2x plus 2. So the y-intercept would be at 2, and the slope would be negative 2x over 1. So your graph should look something like this. Now we're going to verify that these two functions are inverse. So in order to do that, you want to plug in the x for this function into the other function and do it vice versa. So here we plugged in g of x for f of x here, and we plugged in f of x for g of x here. So now what you want to do is take the numbers from the f of x, these two coefficients, and put them in front and behind of the x value. So 2, and the x value is 1/2 x plus 2, and then put the minus 4 behind it, and then do the same thing for the other side. So now that we've done that, we're going to distribute the coefficient here to multiply by the x value. So 2 times a half would be 1, so just x plus 4 minus 4, which equals x. On this side, half times 2 also equals x. Minus 2 plus 2, which equals x. And if x equals x, then they're inverse.
So hello guys, so on to the next problem, which I will be doing is y equals x minus 2 cubed. And what we're trying to do is do the same as the last problem, so it will be x, we're trying to get it by itself, so it will be x equals y instead of x minus 2 cubed. And then after that, what we're trying to do is use square roots to get y by itself, so it will be x, and then it's going to be cubed, and then after that we're going to put this in a square root, y minus 2 cubed, and then we're also going to cube the square root, and that will cancel out the equation, making it x cubed, which equals y minus 2, because this cancels out the square root and we don't need the cube anymore over here. And then after that, we're just gonna keep on solving it, which is gonna be x cubed plus 2, because instead of doing y minus 2, we're gonna be doing the opposite, which is plus 2, which will give us the equation of y. And therefore, the inverse relation is going to be f, and then f of x equals cube x plus 2. So basically, it's going to be, the inverse relation is what we got for y, which is this.
So what we're going to do in this simple example is turn this function into an inverse function, and in order to do that, you first want to interchange the y and the x. So instead of f of x on this side, it would become x equals y plus 8 over 2. And then once you finish that step, you want to multiply the x by 2 in order to get rid of it on this side. So what you want to do is turn this into 2x equals y plus 8. And then from here, you subtract the 8 in order to get y by itself. So 2x minus 8 equals y. Once you get your y value, now you want to change it into the inverse, which is f negative 1 of x equals 2x minus 8.
So for this next problem, we're going to verify that these two functions are inverses. So what we're going to do, we're going to bring down this 3 here, and put some parentheses here, and then bring down this negative 5 over here. And so what we're going to do is basically bring in this inverse function. We're going to bring it all into here. So it's going to be 1/3 x plus 5 over 3. And your next step is to distribute the 3 over to each part. And basically we're going to find what x is. So this would be x by itself, 1x, plus 5 minus 5, and 5 minus 5 is 0, so you're left with x. And then for this next part, you're going to do the same thing. You're going to have 1/3, the parentheses, 5 over 3, and then you're going to substitute these numbers into here. So it's going to be 3x plus, minus 5. And then again, you're going to distribute this over here. So you'll get x minus 5 over 3 plus 5 over 3. And a negative and a positive, they cancel out. So you're left with x. And if these two equal x, then that means that they're inverse functions and that they're related. So, yeah.
So what I'll be trying to find is
Wait, can you start all over? I'm sorry.
Yeah.
Go ahead.
Here's another example, and what I'm trying to do is find the inverse relation of 3x minus 2. So we're going to get y by itself, so it will be y equals 3x minus 2. And then we're gonna get x by itself this time. So it will be x equals 3y minus 2. Basically, we just switch the variables, which in this case is x and y, and in this case is y and x. And after that, what we're trying to do is get 3y by itself in order to get y by itself. So we will add plus 2 and then plus 2 on both sides, and this crosses out, leaving us with 3y equals x plus 2. And then what we have to do next is divide by 3 on both sides to get y by itself. So it will be y equals x plus 2 over 3. And in this case, we're trying to find the inverse relationship. So we will have to do f -1 x equals x plus 2 over 3. And yeah, that's the answer.
So, to tell if a graph is an inverse function, well, let's take for example this one. Here, the graph, you can basically cut it in half horizontally at this point here, and it's equal, so that's an inverse function. However, let's take for example a parabola, this one here. If you try to split it in half horizontally, you can't do that because it's not equal. Let's say here, well, it's not equal because this is like a semicircle and these are just like two rays, so it's not an inverse function. But this is, because you can cut it in half and it's equal.
It's erasing. It's not. It's not drawing.
To a set of possible outputs where each input is related to exactly one output.
Should we do it again?
No. Just continue.